of the Interuniversity Consortium for Political and Social Research. And then finally, we have Mobility and Mortality, exploring level-dependent effects of intergenerational mobility on life expectancy. And that will be presented by Kelsey Carlston of Gonzaga University. So I guess we'll get started here with David, if you're ready.
Thanks, everyone. On behalf of Sara, Amber, Katie, and Trent, I'm excited to share some initial results of a data set, which we hope will create some new understanding around the impacts of the GI Bill. It's very much a work in progress still, so I appreciate being in the methods and resources and not in one of the more impact-based sessions, but we hope that this will have a future impact, and we really look forward to your feedback and ideas as we move forward. Today, I'm going to share a little bit about our research motivations before jumping into our process, and then talk a little bit about the future of this work. So motivating all of this work is we undertook this big project in order to better understand the impacts of the post-World War II GI Bill mortgage program on individual veterans and their families, potentially even multi-generationally. We have an interest in examining the racial equitability of the program's implementation and the impacts any racial inequality may have had. We also want to explore the relationship between the program and racial disparities in housing and life course outcomes. Again, still a work in progress, so spoiler alert, we won't be resolving any of these in this presentation, but high hopes. As a little bit of background, we focus on a collection of paper-based records from the administration of the Servicemen's Readjustment Act of 1944, commonly known as the GI Bill. The GI Bill provided a lot of different benefits to men and women who served in World War II from the United States military, including granting 2.4 million guaranteed mortgages for houses, farms, or businesses between 1944 and 1952. There's been a ton of research done in this area from sociologists, economists, historians, and a host of other disciplines, but what they all have in common is they've all used either summary statistics or proxy data or qualitative data, because we haven't had any administrative records about the GI Bill until hopefully now. What we have is a subset of administrative records that are held at the National Archives. It's called the Index to Loans on Veterans Administration Guaranteed Mortgages, a very jazzy title. And it's a collection of over 24,000 3x5 cards. It's cutting edge data collection, but it's actually really great. Here's an example of one of our cards. And that second one, you can see as I kind of go through here, they're relatively standardized in format. They have the name and the name of the mortgager, the city and state of the mortgage, as well as the amount, and then a bunch of other good information about the mortgage. It's not as structured as a form would be, but our hope was that because it's typewritten, because it's semi-standardized, we'd be able to convert these data into a tabular data set and then be able to analyze them, and other folks could analyze them as well, since ICPSR is a data archive. Here's our workflow. We scan the paper records, digitize the images through optical character recognition, which we call OCR, and then parse that OCR text through various methods, which I'll get to, and to convert that into a tabular data file, which we then link to existing data. I'm going to kind of skip through some of the earlier stages because we've documented that pretty well. We have a forthcoming article on the digitization and parsing, and it's coming out in the Journal of Documentation soon. So just a little bit about our digitization. Well, first of all, I want to say thank you to the staff at the National Archives, some of the digitization team there, because we were doing all of this during various stages of COVID. National Archives was accessible, less accessible, not accessible to researchers, and we luckily had a really created a great relationship there, and were able to have the data scanned by their expert staff. So we have these high resolution images of each of these cards. Then we tried to digitize them using 5 different methods and ran a couple of different measures to see what's the best. Our favorite measure is flexible character accuracy, just because it doesn't take word order into account, which is less important for something like this than say like a prose document. The best method based on flexible character accuracy was tesseract. Parsing and cleaning, we again tested different methods. We used regular expressions, named entity recognition, and document image analysis. So regular expressions is just pattern-based matching. Named entity recognition is a machine learning, natural language processing type of method. And then document image analysis is a deep learning method of combining layout with OCR into one big step. And in this case, both regular expressions and document image analysis were head and shoulders above named entity recognition. And then they kind of competed back and forth depending on the field. So we moved forward with the parsed data from both regular expressions and document image analysis because some of the fields were better from one versus the other. And we kind of like made a winners column and an alternative column so that we could go back to it. Okay, so this is the part I really want to focus on, and that is the linkage of these data. It's our most recent work. We were doing this right up until we got on the plane to get here. The index cards record a lot of information about each mortgage, but not a lot about the mortgagor. And that's the group that we're really interested in. We want to know more about these veterans. And so in order to learn more about them, we wanted to link other records to these records. So we look at enlistment records, census records, Social Security records, and death records. And through all of that, we can learn more about the life course of these vets through their race, aging, mortality, and other variables. Our linkage data sets that we use, therefore, were the World War II enlistment records, which are publicly available from the National Archives. We collaborated with Andy Ferrara at University of Pittsburgh, who has recently digitized and merged the casualty records onto the enlistment records, which is really helpful because as we were doing this work, we were like, man, wouldn't it be nice to not try to link the folks who didn't make it back from the war because they didn't buy houses, and therefore we're not going to get these false links. And so when we found out about Andy's work, he was gracious enough to share his data with us. And then because we're ICPSR, we're in the process of curating those data, and they should be released this, I want to say this month, but I'll say this fall to be conservative. Then we have the team at Sensoc at Berkeley, who has merged the enlistment data onto the IPUMS full count 1940 census and the death master file from the Social Security Administration. As you can see, the record count there is much smaller. So we would anticipate, because we don't have a full pool of enlisted folks, we probably won't get as good of a match rate. And then we also are looking at the Social Security Administration's numerical identification file, which is based on Social Security applications. That is by far the biggest one that we attempted to link to. Okay, so linkage keys, those fans of historical record linkage are going to frown because we have very few linkage keys. As you could see from our index cards, we basically have name and then city and state where the mortgage is. And that the mortgage is made somewhere between like 1946 and probably the early 50s. I'm actually guessing that they're made only in the 1940s, but we're going to look into that more as we continue to flesh out what these data really are. But so the mortgages are from post-World War II, and everything else that we have at this point until IPUMS releases the 1950 census, which we're really excited about. Everything else is pre-World War II. So we've got enlistment records, which is, it's got the county and state of where you lived before you enlisted. Then the the merge data also have the city and state of residence in 1940. And then, the farthest back is the public numinant file, which in this case has the city and state of birth. So there's the biggest gap there. So we'll talk a little bit more about that in our assumptions. So our linkage methods, we blocked on last initial just so that we're not trying to take all the records against all the records. We did fuzzy matching on most of the string variables using SAS, and then used an exact matching on state. The numinant file we limited to men born between 1891 and 1928. I'm sure that there are some outliers that we would have missed, and there are at least 2 women that are in our GI Bill records, but just for the sake of more successful linkage, we are starting with this, and we'll probably go back and hand link the female vets. So our key assumption here is that if we have 2 potential name matches for a mortgage, that the person who had previously lived in the city or county is more likely to be the correct match. Not 100% sound assumption, but probably a decent assumption. David Bleckley from Arkansas and David Bleckley from Michigan, with a mortgage in Michigan, it's probably the Michigan guy. Okay, so how did we do? We had overall, the second to the bottom row, you can see overall we linked the records to at least one of these data sets 85% of the time. 10% of the time we linked it to all of them. We were most successful with the enlistment records. It makes sense if you think about, you have a set pool of folks, that these vets were enlisted in World War II. Here's almost the whole universe of folks who were enlisted in World War II. There are folks missing from that data set, but it makes sense that we had the most success there. Looking at some of the variables that we had hoped to glean, we were able to assign race to 79% of the records. And again, if you looking back, we only had 10% that were linked across all the data sets. So when we compare again, and within that little 10%, 74% of them, we had consistent race over time. And again, well, we can talk more about race if folks are interested in that during the Q&A. Again, we also wanted a birth and death year. So 81% of the time we had a birth year, and 30% of the time we were able to get the death year, which is because of those SenSoak records, we only had a smaller number, and we linked to 30% of the SenSoak records. In the future, we're hoping to be able to use these for comparative analyses, disparity analyses, and spatial analyses. One of the co-authors of this paper is a geographer by training, and she's already doing cool spatial analyses of the output. So our next step is to further validate our linkage, strengthen our linkage by pooling all these results together and finding using things that we glean from one set to link to other sets, and then create recommendations for our linked variables and curate and archive them, link to the 1950 census again, and then way in the future, we're hoping to link these into the Census Bureau's data infrastructure. So thank you, and thank you to the 2 little grants we got from the University of Michigan to do this work.
Okay, thank you. I've changed my slides a little bit from what's posted online to reflect that this session is called Resources and Methods, which is convenient because I think the resources and methods here are more interesting than the results, potentially. But okay, so the question that I'm asking is, how does intergenerational economic mobility affect mortality? And I'm looking at level dependent effects. So you'd think that this would be something that'd be studied a lot, but I think it's kind of hard for people to conceptualize why mobility would affect health. So we know that father and son economic status affects health through a lot of different ways when the boy's a child and when they're grown up. Their economic status and resources affect their stress levels, their access to health care and health behaviors and all kinds of other things. So we would generally expect health outcomes to be like the economic impacts to be a weighted average between father and son status. So, even if a kid goes from being poor to being rich, their poor childhood will have an effect, but their current status will also have an effect and maybe have a stronger effect. So separate from that, the question is there an effect from moving statuses? So some people have done work on this, and generally there's reason to believe there would be. So for the upwardly mobile, we imagine that more hard work, it may take more hard work and stress to achieve a high status compared to somebody who was born high status for a low status person to get there. So that's bad for your health. Stress is not good. But you may feel extra good because you started from nothing and you ended up in a high position. So that's good. For the downwardly mobile, there may be stress from losing status. You feel a little bit like a loser, and that's bad for, your mental health, which affects your physical health. So that's bad. And then for both of them, if you move statuses, that often means leaving communities behind, leaving the people that you care about, and having some kind of social isolation, and that's bad. So there's a lot of reasons to believe why, even though we like intergenerational economic mobility and there's a lot of good things about it, it may not be so good for your health. On the other side, there is a chance that the health affects your individual mobility. So if you have bad health, that might be a reason why you have downward mobility. For this study, I don't think that it's a huge effect because if your health is affecting your economic status when you're 25 to 30 years old, I think it's less likely to show up when the deaths that I'm measuring are deaths past age 65. But there's this pathway. And then also there's a chance that some omitted variable is affecting individual mobility and health. Maybe, your drive to move up also gives you different health behaviors. So this study doesn't look at causality, but I am linking individual mobility and health. And then I'm also linking a geographic measure of intergenerational mobility and health. So besides the people who themselves are economically mobile, I think that people might be affected if they're in high mobility areas. So areas with high mobility may have more vitality and hope and less despair. So higher mobility places often have better economies, higher social capital, less segregation, and lower inequality. There's been aggregate level studies looking at the relationship between deaths of despair and economic mobility, and those are related. And the benefits of upper mobility may spill over to the non-mobile. So even if you're not moving, seeing people around you being able to move, better their position is a good thing. And I'm not sure that I believe that the drawbacks would, but we'll see. So other studies have looked at the relationship between mobility and health. So geographic studies have found strong results showing that intergenerational mobility is related to better health and longer life expectancy. But the authors tend to say, well, this means that mobility is good for people. And aggregated studies are often misleading, and you can't make those generalizations about individuals. The individual studies that look at the impact of mobility are often mixed. So you have, it's kind of hard to measure this thing, and I'll talk about that more. And no studies look at both together. So that's what I'm going to do. The data that I'm using full count census data. This is a cohort of white boys from 1910 to 1915. I linked to their father in the 1920 census, and then to the son in 1940, using the census linking project link. So I didn't make my own links. That's a heavy lift for the people before me. But I use a census linking project, and then I link those records to the death records from the Censoc, where they link to Social Security records and reported on deaths from 1975 to 2005. So for my cohort of boys, that's when they're about 65 to 90. So going through all the linkages, it's the white boys born between 1910 and 1915. I'm only using white boys because it's hard, because linkages, at least using the Census Linking Project, linkages for minorities are very biased. So this cohort has about 6 million boys, but for each step of the linking process, I lose a fair chunk of boys. I also take out farmers and military because those occupations, you can't really impute status on them because there's a lot of heterogeneity in what those statuses or within those occupations. So you can be a poor farmer or a rich farmer, but your occupation is going to be the same either way. And I also remove fathers and sons without occupation. So at the end of all this, I have 240,000 records, which is still pretty good, I think. The other variable, so I'm using the earnings score quintiles for fathers and sons. So I turn into categories. And then for the geographic measure of intergenerational mobility, I use measure from Connor and Storper 2020. So here they go up to the state economic area and they're looking at the expected income rank of sons of poor fathers. And their cohort is 1900 to 1915, so it includes mine. And then I have the age of death between 65 and 90 years old. I also have some other individual and geographic covariates, and I include state fixed effects. So the model, it's kind of a hard question to say, how do you estimate the effect of a variable that's a linear combination of other variables, which mobility is? You're taking son outcome minus father outcome. So you can't just throw it in normal regression. So there's a few ways of doing it. The most popular one for the last 20 years or something is the diagonal reference model. So what this does is uses the weighted average of this non-mobile core. So if you didn't change income quintiles from your father, you're measured as the baseline for what effect that status has. And then anything that deviates from that for the sons that did move quintiles, those are the mobility effects. And the way this works is you can see what the effect of upward mobility is or downward mobility is, but you can't see the effect of the size of the move. So a different model that tries to look at the maybe nonlinearity and effects is the mobility contrast model. So this was proposed in 2022, and they use all the people in the origin and destination status to estimate the effects. And then for each father-son income category, you can get a different measure for what the health effect is. So it allows for nonlinearity of mobility effects, and maybe when we get to the results, that'll make more sense. I'm going to skip this because I don't think we have time and it's not that interesting. So this just shows that we do see sons' earnings ranks and fathers' earnings ranks are positively affected with life expectancy at age 65, but it's not a huge change. So to go from the lowest level to the highest level for the fathers is about 0.8 years, not even a full year. And then for sons, it's about 2 years. So these effects, while they are definitely there and significant, are not huge, which is, I think, fairly normal for when you're looking at life expectancy at age 65. So the diagonal reference model, what this shows, okay, the first line where I have the weight on son status, that pretty much shows that the status of the son when they're 25 or 30 is more important than the status of the father. The weight is 0.8 compared to 0.2. Downward and upward mobility at the individual level don't have a significant effect, but the effects are negative. And then county level mobility has a significant negative effect, but it's not very large. It's about a third. So these are standardized. So one standard deviation increase in county level mobility is associated with a negative 0.05 decrease in life expectancy, which is about a third the size of the black share. So the mobility contrast model shows something similar, but here you can see the results change are different when you get further, when the son jumps further away from the father. So that center line is the non-mobile core. Those are the blued out boxes. And then the ones next to it where the sun is only moving one step away, there's not a very big effect. It's not significant. Then you move further away and there's, one of them is significant, but they are getting larger and more negative. So moving from your father's quintile for a lot of reasons may be negative for your health. And some of these have fairly small sample sizes, like to move from the father fifth income quintile to the son to have the first income quintile, that's only about 1,000 kids. So it's not a very big sample size. And then again, we see the geographic level upward mobility is significant and negative. So in conclusion, I think there's limited weak evidence that mobility is not good for individuals' life expectancy, but it's not a very strong effect in any case. There is still an active conversation around modeling these effects, but it also might be maybe mobility isn't as big of a predictor as a lot of other things. But if it is, given the small negative effects, it's worth thinking about what kinds of things can ease the blow of, getting disconnected from your community. Geographic upward mobility is negatively associated with life expectancy. This isn't causal, but maybe it's the aggregated effects. If I take the geographic level out, then the individual level effects do get stronger. So maybe it's some aggregated effects or some omitted variable bias. And maybe they're just stressful places to live. And more work, I think, is needed to understand why there's a difference between, or why intergenerational mobility might have these negative effects. So thank you.